We are getting really, really close. Remember the save the date I gave you. If you lost yours or need one, I have extras. But it's coming up in just a little over 2 weeks, our mock exam. I realize not everybody can make it. It would make your life easier in the long run, believe it or not, to come to that. So if you're like, I just don't want to come, I'm going to tell her I'm out of town or whatever, rethink that. I know there are some people that really can't come that day, and that's okay. I'm not going to punish you for it. It's just you're going to have to do all the parts of the AP exam on your own time instead of getting it all done on this day with your classmates. And the whole reason I'm doing this is not to save time in class. It's because I want you guys to feel the feels of what it's like to do 4 hours of math straight, okay? I'm timing it the same exact way, all of that. So I'm just reminding you it's coming up on that April 18th. We start the test at 8. You can come as early as 7:30 to eat breakfast, okay? So that's optional if you want to come. But all that information is on here. I will keep reminding you, and I'll have like a sign-up sheet next week. So Ms. Springer's Calc kids, Ms. Bunday's statistics kids, and of course my pre-calc kids, we know how many are coming because we buy food for you guys and all that stuff. And last year we bought way more than we needed. But we'd rather have more than not enough. Okay. So guys, we are starting 3.14 today, finishing it tomorrow. We're actually graphing polar functions, the equations, okay? We've already learned how to graph the points, and we're going to practice that here, but we're going to learn how to graph the equations, and they make pretty pictures. There are 5 different types. They make circles, we make hearts, we make dimpled limicons, we make limicons with inner loops, and we make rose curves. And all 5 of those shapes you're going to learn between today and tomorrow. Believe it or not, you're going to learn 4 of the 5 today. So we're going to do all of them today except for rose curves. Tomorrow we'll do that. There's just a bunch of different types of rose curves. They look like flowers. They have different number of petals and stuff like that. Today, you're going to think this is really easy, especially by the time I'm done. You'll finish the homework in class with time left over. But this is brand new stuff, so please, please, please do me a favor and really take good notes and pay attention, and that way you learn all the little tricks, and then it's just, once you get to the homework, you're going to be like, oh my gosh, this is so easy. Like, you really are, okay? Know that on Friday, I will be introducing the poster project. I will be giving you guys a rubric. I will show you the types that I'll show you all different examples, ones that are people that got a perfect score, but their picture is not so cute, okay, like what I would draw. People that had gorgeous artistic drawings, but didn't get perfect scores because they didn't follow the rubric, and everything in between. And I'll make a video of me doing that in case you're not here, but that's Friday, due next Friday, or sooner. I'll take it Monday if you want. The sooner you get it into me, the sooner I can I put that quiz grade in for you and drop your other quiz, okay? So, and 3.14 is what section this quiz grade, this poster comes from. So today and tomorrow you want to have good notes, so you can use your notes to make sure you cover everything in your rubric and you're good. So, like I said, we're graphing polar function graphs, and there's really 3 methods, okay? The first method is the point plotting method, which is just making a table of values, and we'll do that. The second method is the one you're going to like the most, and that is knowing basically 3 things. You can make all these graphs in 3 seconds or less, literally. Every single graph you can do in like 3 seconds or less. And then, which is the way we'll do it in our homework, by the way. And then the third method is using a graphing calculator, which I'll show you tomorrow, okay? So first method is the point plotting method. Why would we use this method instead of the second one I talked about that makes it really quick? There's a couple reasons. First is, for the project, you will be required to make a table of values with at least 4 points in it. So you will have to know how to do this. Second is, making a table of values for any function and graphing it is a great skill to have in your back pocket. If I told you guys to graph, don't write this, if I told you guys all to graph this quadratic, okay? Back when I taught you quadratics or Algebra 2 or Algebra 1, there was like a negative b over 2a, and then plug that in, you get your vertex, axis of symmetry. There's all these like little cutesy trick ways of doing it, but we don't remember those all the time. So you're taking the SAT or you're taking a test and you don't remember how to graph something, you make a table of values and you pick a bunch of numbers, right, and you plug them in and you get them. So knowing how to do a point plotting method for any graph is a great skill to have. So we're going to start with that, and then you're going to see how much easier it is to not do this, okay? But it's a good thing to know, and you have to know it, okay? Also, your FRQ on next Friday's test, you have to make a table of values and graphs. So this is an important skill to know. So we are given an equation, see r and theta, that tells us it is polar. They already made the chart for us or started it for us. They gave us a bunch of thetas, and we're going to plug those in for theta and get our r value. To kind of speed it up, because we're going to do 2 of them, I'm going to look at my thetas. Notice they're all unit circles, standard angles, and I'm going to just, so I have it to look at, my denominators of 6 would be this ordered pair, right? My denominators of 3 would be this ordered pair. Cosine, sine, right? Cosine is x, sine is y. And there's some quadrantals. So, and this is absolutely optional. It makes my life easier, me personally, just to have it to look at, and then I can just grab what I need. But you obviously don't have to. Sorry, Riley, you want to sit one back? Or anyway, yeah. Okay, so any of those, optional, but it just makes my life easier. Okay, and now we're just going to plug and chug. Sine of 0. So theta is 0. Sine of 0 is the y value, would be 0. And 4 times 0 is 0. Now, I'm not showing a bunch of work, nor do you have to. When I need to, I might write some little math over to the side in the margin, but I don't need you to show any work here. Pi over 6, so 4 times sine of pi over 6. Sine of pi over 6 is 1/2. Sine of pi over 6 is 1/2. So I have 4 times 1/2. Remember, you can cancel diagonally, so that would be 2. Keep going. 4 times sine of pi over 3. Sine of pi over 3 is the square root of 3 over 2, right? 4 times the square root of 3 over 2. 4 over 2 becomes 2. And left with 2 square roots of 3. Pi over 2, sine of pi over 2, that's up at the top. Sine is the y value, that's 1. 4 times 1 is 4. Now these two are in quadrant 2, right? The numerator is 1 less than the denominator. So do I need to change the SIGN of the SIN for these two? No, because in quadrant 2, cosine is negative, sine is positive. So I just wanted to make a quick mental note of that. I'm going to actually get the same answer as I got over here. Because sine of 2 pi over 3, my denominator of 3, sine is square root of 3 over 2 times 4 is still going to be this. My denominator of 6 is going to be the same. And then at pi is over here. My sine value is 0. 4 times 0 is 0. Okay? So annoying, but it shouldn't be difficult. And I know I went kind of fast through that, but you could write out as much work as you needed to or felt you had to if you were doing one in this manner, okay? Now let's sketch the graph. It's kind of hard to do because our circles are really faint. I don't know how faint yours are. I think they're faint as well. And we've got a lot of whole numbers in here, 0, 2, 4, and so on. But 2 square roots of 3, when I put that in my calculator, I get approximately 3.5 because I need to know how to graph 2 square roots of 3. So I just put it in my calculator. So that'll be approximately 3.5. So this is a great review of how to graph polar points, okay? So first thing I want to look at is they made the graph for me. I didn't have to draw it. And notice that, and I know it's really faint, maybe look at yours, but there's a denominator of 6, a denominator of 4 line, and a denominator of 3, right? 6, 4, 3. So I don't have any denominators of 4. They didn't give them to us. They could have, but they didn't. So we don't have any points on the pi over 4 line, but that's okay. It doesn't matter. We'll just graph what we have. So if I go out to 0 and then out 0 radians, that's just at the pole. Anytime r is 0, your point is right at the pole or the origin. At pi over 6, which is this denominator right here, I'd go out 2 circles. At pi over 3, which is up here, right, 4 is in the middle, I would go out 3.5 circles. So somewhere between the 3rd and the 4th circle. Do the best you can. Looks about right there. That look right? Yeah. At that pi over 2, I'm going to go out 4 circles. At 2 pi over 3, that would be here, right? Denominators of 3 hug the y-axis. I would go out about 3.5. Then at 5 pi over 6, which would be this one, I would go out 2 circles and then back at the pole. What this is a circle. Not a very pretty circle, but it's a circle. Riley and Caitlin that came in late, I did go over a whole bunch of important stuff at the beginning of class, so you might want to at least watch the first few minutes of the video. Okay. All right, so let's do another one. I'll go a little faster through this one. It's still denominators of 6, denominators of 3, and some it's the same theta. So I'm just going to, that was another reason why I kept those. I'm going to keep those values right there. And I'm just going to plug into this equation. So cosine of 0. So cosine of 0 is 1. So negative 3 times 1 is negative 3. Pi over 6. Cosine of pi over 6 is the square root of 3 over 2. So I have negative 3 times the square root of 3 over 2. Sometimes it helps me to see it instead of trying to do it in my head. You do you. Whatever you need to do is fine. Nothing cancels. Just becomes that. Cosine of pi over 3, cosine of pi over 3 would be 1/2. So I'm doing negative 3 times 1/2 would be negative 3/2, or 1.5, right, decimal, for graphing purposes. Cosine of pi over 2 up at the top would be 0. Negative 3 times 0 is 0. Notice we're in quadrant 2 here. These two are in quadrant 2, and we're dealing with cosine in quadrant 2. Cosine is negative in quadrant 2. So it's really going to be the same answer I got here, just change the sign, right? So I'm doing negative 3 times cosine of 2 pi over 3. So negative 3 times negative 1/2. Just changes it to a positive 3/2. And the same thing with my denominator of 6. It's going to become a positive. Cosine of pi is negative 1. Negative 3 times negative 1 is 3. So in this example, we do have some negative r's. So let's remind ourselves how to graph negative radiuses. Radii is plural. Okay. So up here, no negatives, right? We just went right to each of those angles and the number of circles. But when there's a negative r, we have to shoot through the origin. We go halfway across the unit circle. And let's just put that in our calculator. 3 times the square root of 3 divided by 2, that would have been negative 2.6. This would be positive 2.6, approximately, right? Because where the heck is that point? All right, so let's graph. So out at 0, that's 0 pi. So remember, you can write it as 0 or 0 pi. Out at 0, I would go out 3 circles, but I don't get to stay there because my radius is negative. So remember, you shoot through the origin. My first point would be right there. At pi over 6, which is right here, I would go out 2.6 circles, somewhere between 2 and 3, but I don't get to stay there, so I have to shoot through the origin. Remember, when you shoot through the origin because of your negative r, you end up at the same denominator, just that opposite quadrant. So I was at denominator of 6, I'm going to end up at denominator of 6, okay? So you don't start on a denominator of 6 and end at a denominator of 3 or 4 or something else. So that would be out somewhere, I know it's hard to see, somewhere between 2 and 3 circles. Up to the best you can with those decimals. Okay, at pi over 3, that's up here, right? Pi over 3 would go out 1.5 circles, but since it's negative, we have to shoot through the origin. We'll end up in quadrant 3 at our denominator of 3, which is by the y-axis. So out 1.5 circles, so approximately, okay, let me see, maybe right? That's a 3, that's a 2, let's say that. It's hard to see. Then remember, anytime your radius is 0, you are at the pole. So pi over 2, but who cares, because the radius is 0, we stay right where we are. Anytime pi is 0, almost there. 2 pi over 3, that's quadrant 2. My denominator of 3, that's up here. So 2 pi over 3, I'm going out 1.5. 5 pi over 6, that's here. Going out 2.6, so around here. And then at pi, we're at 3, but we already have a point there, right? These two are the same exact point. Makes a circle. And it helps to hit the points. So what we just learned is this. This equation and this equation, when you see A, which is the number right after the equal sign, right up against a sine theta or a cosine theta, it makes a circle. It's the most basic of all of the polar graphs that we do. And you'll notice when we get to the next page that they're the most basic equation. They're easy to identify. And there's some, remember how I told you this is the not preferred method? That took, not hard, right? But annoying. You're having to remember unit circle and find decimals and graph on in between lines and stuff. So it's annoying, but remember I told you there's an easier method that takes 3 seconds to graph any of these. And I'm about to show you how easy this is going to be going forward. So what we just learned is that a circle can be one of two equations. R equals either a positive or a negative A cosine theta, or R equals either a positive or a negative A sine theta. Okay, so you can have a positive A or a negative A with either cosine or sine. And when you see the cosine or the sine with the SIGN of the A value, that's going to tell you where your circle is, and you draw it really quick. Here's why. Here's how. Remember, cosine is x and sine is y. Think of this axis, your x-axis, think of it as the cosine axis. Cosine and x go together. Okay, think of this as the cosine axis. I totally made that up. I don't think it's ever been called that, but it goes with x. And then this is your y-axis, of course. We would think of that as our sine axis. So let's go back to the first one. That was a positive 4 with sine. Notice all of our points were skewed positive y-axis. Positive y's, the sine. Look at our negative with a cosine. Cosine is either left or right. Because it's negative, it went to the left. That will always happen. So if I gave you this, y equals 2 cosine theta, guess where the graph is? I would go out to the right, because it's cosine, positive, it would be right here, and I could make that graph that fast. That's how fast you make it. And we'll practice that in the homework. You will not have to do this in the homework at all. Okay? This is a skill we need to know how to do. You will have to do 4 points on your project, so now you know how to do it, but you won't really have to do it again. Okay? Let's go to our second of 2 types that we're doing today, all the way over to page 175. We are making something called cardioids and limicons. There's 3 different types, okay? I'm going to give them my own names because for this AP exam and for my test, you don't have to know the names. You have to know very little about these graphs to be able to graph them. This is where I'm going to ask you to trust me. As I go through these 6 examples I'm going to do, doesn't take very long, don't worry, these are very quick. You're at first, I'm going to predict, I'm going to read your minds. At first, you're going to think, I'm never going to memorize. How am I going to remember to do any of this? I'm asking you to please trust me. You know I tell you when something is hard. This is not hard, okay? And I know this. I've taught it twice a day. I've taught it for many, many years. Everyone thinks these are really easy, okay? Just give me a chance to show you some things before I show you all the little tricks, okay? So we never are going to worry about symmetry. We make these really, really simple for this class. here are the formulas that you're going to be seeing. Notice how they differ from the circles. The circles had no plus or minus, right? It was just A cosine theta or A sine theta. These are going to have a plus or minus in between the A, which always comes after the equal sign, just like the circle, and a new variable, new number, we'll call B, okay? So the first thing you're going to do on every single one of these problems, including circles, when we do it the shortcut way in the homework, like I just started to show you, is we look and see cosine. First of all, the minute I see cosine, I know most of my points are going to be either right or left. The way you tell which direction is whatever the sign is. So that's a plus with a cosine. That means all my points are going to be, or most of them will be to the right. Cosine positive is to the right. Our first point is going to be to the right. How many? A plus B. 2 plus 2 is 4. My first point is to the right 4. That's how we start every single graph. The next thing we do is take the A value. A is 2. That is something I call axis width. Now let me tell you, for this course, for AP Pre-Calc, for your AP exam, these are all going to be multiple choice questions. There's none of them in the FRQ. I think I said that. We don't need to go super, super deep into these, so I've kind of like changed some of the wording and stuff to help you guys memorize stuff. If you take Calculus BC, you go really, really deep into these, and you'll get retaught all of this anyway. But for this class, I'm going to make it pretty simple with what you need to know for my test for the AP exam. Okay, so I call the A value axis width. I came up with this little name. What that means is go to the axis. Remember, we have a cosine and a sine axis. Go to the axis that we don't have any points are, and that's how far from the pole we're going to go. Since it's 2, I'm going to go 2 and 2. The width of that other axis, just what I called it. Okay? That step is the same for every single problem. And then the ratio is A over B. The ratio tells you what type of graph this is going to be. It's either going to be a heart, a loop, or a dimple. I didn't come up with the names. Cardioid is what the actual name is. Cardio, think of a heart, cardio. I call them a heart because that's what they look like. You're going to actually graph a heart in a minute. Okay, so anyway, how do we figure it out? A over B. So 2 over 2 is 1. Anytime you get a 1, that is always going to be a heart. And the way and you know I always have goofy ways of helping you try to remember things, which help me. I just pass them on, use them, think of your own way, whatever. But I think of anytime I get a 1, I know it's going to be a heart. And I think of like 2 people share 1 heart. 1 heart. Just think of that. And that, knowing what type it is, tells me where my fourth and final point goes. Anytime it's a heart, you're going to put a point right in the middle of your 2 axis width problems, like 1 heart in between 2 people. I don't know. That's going to be important when you see the other 2 types. We'll come back to how to remember it too in a second. And then I like to turn my paper. I only have 4 points. You're only going to have 4 points on any of these graphs. And I'm going to make a heart out of it. So watch, and then you do. Heart. That's it. That's a graph. Now, could I have made a big, long table of values, picked a bunch of thetas off the unit circle, plugged those in to there, and gotten these points probably a little more exact? Yes, but we don't need to do all that. Okay? Let's do another one. Remember, sine means up or down. So all my points are either going to, or my first point and most of my points will either be up or down. Because of the negative, that means down. How far down? A plus B is 4. Now listen to what I'm about to say. I'm going to say it so many times it's going to be annoying. The only time we even care about this sign is this very first decision. That negative told me to go down. After that, A is positive, B is positive. Don't overthink it. Everything is absolute value from here on out. So A is 2, and my ratio will be 2 over 2. Okay, not negative 2. Just ignore the negative for the rest of the problem. All right, so down 4, that's my first point, right? Sine, negative sign is down 4. Axis width, So the axis I didn't draw on is here and here, so 2. And then when I do A over B, I get 1. A 1 is a heart. Whenever it's a heart, I put my fourth and final point dead center. It's always going to be on the pole, right in the middle. And then you make your heart. Done. Now what's going to change for the next two is it's not going to be hearts. We have to do something different to make our fourth and final point. But the first 3 points are always done the same way. So let's go to our next type. Next page. Notice again an A and a B with a symbol in between, cosine or sine. Same idea though, cosine is left or right. What direction is this one going to go in? Left. How many? 3. No signs. Don't even say a sign ever again. Remember, that negative was for direction only. From now on, A is 1, B is 2. We just think of everything as being positive, okay? So we're going to put our first point to the left 3. A is 1. Still, it is our width on the other axis, so that's 1 and 1. Ratio is A over B. That is important. It has to be A over B. 1/2 is less than 1, right? It's not equal to 1, so it's not a heart. Less than starts with an L, so does loop. This one is called a loop, a limousin with an inner loop. We never have to memorize these names. Just think less than loop. I need one more point. Remember, we make 4 points. We've done 3. When it was a heart, we knew that point went right in the middle. Okay, it's not a heart, so it's not going to go in the middle. Okay, where it goes is, and I don't even have this formula memorized because you're not going to need to. This is where you're going to start to get a little, you're going to start saying to yourself, all right, I'm going to tune her out because I'm just going to guess on this problem because I'm never going to remember this. Stay with me. I promise you, you will. Just hold the thought. 2 minus 1 is 1. Okay, so this 1 is telling me I'm going to, for a loop, I want to be in between these points. So I'm going to be 1 from 0. I want, like the loop, they're really tight together, okay? Let me tell you in advance, our last type, the dimple, this number would be above them. It makes it like a taller graph. Let me show you what the graph looks like, so maybe it helps you memorize that a loop goes in between. Watch me do it, because it's hard to, I had a hard time learning how to do these, but I have weird spatial awareness stuff that goes on in my brain. So this is how you make a loop. It's not a heart, okay? It's a loop. So it has a loop in the middle right there, and then it kind of finishes like a heart, okay? So you have that point that's below the other two, so you go like this and like this, and it makes like a little loop in there, okay? Let's do another one. Zach, what direction and how many will this one go?
Right.
Nope.
Oh.
Down. Sine is this, sine is Y, right? So if it's sine, my choices are up, oh, sorry. If it's sine, it's either up or down. In this case, it's going to be up. Sorry, I didn't mean to put that. Positive sign. Does that make sense, Zach?
Yeah.
Okay, and you're right about the 3. First point, up 3. A is 1. So on the other axis, 1 and 1. I need that final point. Where does it go? Depends on your ratio. A over B, that's less than 1. Less than is a loop. So think of less than, I'm going to go like in between these sets of points. I have to have a point. Where does it go? That's when you do your B minus A. Now listen. In a minute, let me just tell you ahead of time. In a minute, I'm going to do A minus B on these. And you're going to be like, how am I going to remember if it's B minus A or A minus B? I don't have it memorized. But remember how we don't care about signs? So just know you subtract these two numbers. Whether you do 1 minus 2 or 2 minus 1, you get 1. Whether you do 1 minus 2 or 2 minus 1, you get 1. So don't overthink the order of these letters. Just know how do I figure out where that other point goes? I just subtract these two numbers and keep the answer as absolute value. It's always positive. So it's 1, and it's going to be in between if it's a loop. So it almost looks like a Y, right? It almost looks like a Y. And then you make your loop. My loop doesn't look so good. Okay? Last type, and then I'll sum it all up for you and make sure you understand how manageable these are. Chase, what direction am I going to go on this one? Not up, to the right. Cosine is left or right. Do you get that? Yeah. Cosine is left or right. How many, Chase? Redeem yourself. How many? 5. Good. To the right, 5. Right? Cosine is left or right. Sine is up or down. To the right, 5. First point. A is 3. 3. 3. A over B is greater than 1. I had my way of helping you memorize heart and loop. I don't have anything for this one. Just know it's the last type. It's got a dimple in it. And whether you do A minus B or B minus A, you're going to get the same answer. Technically, the formula is A minus B, but it really doesn't matter. Whether you do 3 minus 2, you get 1. 2 minus 3, you get negative 1. And remember, we don't care about signs. So either way, you get 1. That tells us where our fourth point is. So let's recap. If it's a heart, it goes right in the middle. If it's a loop, it goes down close to your other point. This is the opposite. It goes the other direction. So let me turn it. So remember, heart would have been in the middle. Loop would have been down here, and it would have looked like a Y, kind of. 1 on the dimple, the greater than, it goes above. And dimples are the hardest for me to draw. They kind of look like a guitar pick or a peach. So it goes like just a tiny dip in. Kind of like that. It's almost like a heart drawn badly. Here's a better looking one. Like that. They can even look kind of like that. They're just hard to draw. So I always think of like an acorn, a peach, a guitar pick, something like that. Okay? They're the hardest to draw. Last one. Jackson, what direction is this one going? Down how many? Yeah. Negative sign. That's down. A plus B, 7. So, 7. A is 5. So 5 and 5. So that's the same every single problem. This is the only different part. So A over B is clearly greater than 1. It means it's not a heart. Less than is a loop. Oh, it's got to be the dimple. And again, whether you do A minus B or B minus A, you should get 3. And I have to remember the dimple is not the one in the middle. It's not the one that goes closer to my first point. It goes above. It makes it taller. So 1, 2, 3. And then make a dimple. So let me tell you what a multiple choice question would look like on the AP exam. Because again, you will not have any of these in an FRQ. On the AP exam, they might give you this question right here and give you 4 graphs and say, which one of these is the graph of this function? And you would say, oh, I remember that quick trick, negative sign. My points are going to be skewed down. Yes, there are points other places, but the point that's furthest from the pole is down. So you might have one that goes down, goes to the right, goes to the left, goes up. So you would have to identify which one is which. Okay? So knowing these basic things, if it equals 1, it's a heart. If it's less than 1, it's a loop. If it's greater than 1, it's a dimple. And knowing where that gives you that fourth point, right? In between, under, or over. And then A, and remember, it's always absolute value. is your axis width, and absolute value of A plus the absolute value of B, I'm calling it like directional distance. That's that first point. I'm going to write that. This is your first point. These are your second 2 points. And then this gives you your fourth point. So for all these graphs, you will have 4 points and 4 points only. Okay? Let's go to the homework. And I'm going to do 1 through 4 with you. That leaves 3 for you to do. We're on page 181. And some people usually pick up on this. I don't know if any of you did. This homework assignment is D11. Yesterday was D9. We skipped D10 on purpose because I cut it. And I had already numbered all my homeworks and made my lesson plans and put all of the assignments in Canvas. So I didn't want to have to renumber everything. So just know we do not have a D10. D10 does not exist. You're not missing it. It doesn't exist. All right? So let's do 1 through 4 together. All the shortcut way. No tables of value unless you wanted to practice those. Okay? So look at number 1 and number 2 right off the bat. These look different than the ones we just did, right? There's no plus or minus and there's only one number. These are what type of graph? Circle. And like I said, you can graph a circle just as quick as the other ones, quicker even, okay? This is a negative sign. Down, the only number in there. Down 4, make your circle. Remember how long that took to do in our first example with that table of values? There's the quicker way of doing it. In multiple choice, that's all you need to know, right? Cosine, positive 3. Cosine is right or left. Positive would be to the right 3. And you just don't go past the origin, so you have to know that. It goes out and then doesn't go past the origin in any of these. All the points are either down, right, up, or left. Okay? Then notice we get into the other type. We have an A and a B with a plus or a minus. Okay? So sign being positive would mean up. A plus B, 4. First point, there. Second 2 points, so the second and third point, are determined by our A value. 2. 2. The ratio, which is always alphabetical order A over B, tells us the type. 1 is a what? Heart. So here's the memorization part. A heart, besides knowing 1 is a heart, is where my fourth point goes. So that's why I was trying to tell you, like, 2 people share the same heart. The heart is in between the 2 people. I don't know. Think of how you want to memorize it. And then you make a heart. Right? What direction on number 4? Left, how many? A plus B. A over B. Notice I am ignoring that negative. We don't care about the negative except that very first part that told us what direction. After that, everything is positive. A and B are positive. Don't overthink it. That is greater than 1, right? 4 over 2 is greater than 1. Greater than, it's not the less than loop. It's not the 1, which is a heart. This is my dimple. So, guys, it doesn't matter if you do 4 minus 2 or 2 minus 4. Technically, on the dimple, it is A minus B, but it doesn't really matter. Remember, this is multiple choice. You just have to know how to figure out where that fourth point goes. Whether you do 4 minus 2 or 2 minus 4, you're going to get absolute value of 2. And dimples are taller. They're the tallest ones. So there's just a little bit you really have to know to tell the differences. Gosh. Okay? So I did 1 through 4 with you. You have 3 left to do. Tomorrow we'll learn about rose curves, which are flowers that have petals.